it's time to get to the real deal. We've created our first HTTP server, but we've seen that the functionality built into Node is pretty bare bones. We need to write all that code to handle the various situations that we encounter all by ourselves. But building servers is something that many people do in Node. So let's find a more convenient solution. You see, developers are lazy, but lazy in a good way. When we figure out how to do something well once, we don't want to keep doing it over and over. If we run into cases where we're doing similar things over and over, we build a tool or a package for that task. And that tool can then be applied whenever we're faced with that task. A task like building a server, which has been done so many times before. There are many packages that we can use to help us build servers in Node. But the most widely adopted, without a doubt, the most dominant, and the best to learn is Express. The Stack Overflow survey is this developer survey that's run every year by this site that most developers love for the amount of times that it helps us answer our questions. And the survey asks developers about the technologies they use, what their favorite programming languages are, what tools they use, and what they're forced to use versus what they actually enjoy using and what they'd like to use. I recommend you check it out. But if we go to the most popular technologies and we scroll under to web frameworks, we can see that Express is the most popular backend framework for JavaScript by far. In fact, it's one of the most popular frameworks in any programming language. The other Node frameworks that we might use on the backend don't even make the list. The same thing applies if we look at the most loved and wanted frameworks on the web. We have Express sitting right near the top. It's tried and tested, easy to use. There's plenty of information and tools around it, so if you ever get stuck, you're able to find the answers you need right away. It's used widely in production in the top companies in the world, including places like Twitter and Uber. And it's the basis for all of the other Node backend frameworks. So let's learn some Express. We're going to be working from this Express project folder, which I have opened here in VS Code. The first thing we need to do is to initialize our project using npm, because we'll be installing the Express package from the npm registry. So we'll do npm init-y. And now that we have our package.json, we can install Express. So our Node modules now contains Express and all the dependencies that Express relies on to allow us to create servers. And we'll create our Express server in an index.js. What we'll do is import our Express package, and the way that we create a server should look very familiar to us now. We set up our application using the Express function that's exported from the Express package. We'll set a port that we want our server to be made available on, say port 3000, just like before. And then on the server that's returned from this Express function, we'll call the listen function, which is exactly like the listen function in Node's built-in HTTP server. We pass in the port, and we can also pass in this callback that runs when our server starts. And we'll say that our server is listening on the port that we specified. Now in my terminal, because we've initialized our npm package, we can start our application with npm by calling the start script. And for this to work, we'd need to add start to our list of scripts in the package.json file. But because servers are what Node is built to do, there's a special case, which is if our file is called server.js, running npm start will run that file. So I'll clear my terminal, and our Node server is running. Now in the browser, we can go to localhost at port 3000, and we get a message that we can't get / because, well, our server isn't set up to return anything. If we go to our developer tools, we can see that Express responded with a 404 not found page without us having to do anything, which we'll also see in the network tab. If I refresh the page, we get the status code, which was set by Express to make our lives easier. And this is where the real power of Express comes in, which is that it's really good at routing. Let's take a look. Say I wanted to respond with a hello message when the browser goes to that / route. Express allows us to use the app object to respond to these requests by writing app and then the name of our method. So we can specify a method like post or get, and then the path to that route or endpoint. So let's do / followed by the route handler function, which is the callback which we pass in the last parameter. And just like in the Node HTTP server, it takes a request and a response object. But these two objects are a bit different than Node's built-in HTTP server, where the response object has this convenient send function, which allows us to pass data in the response. So we could write hello, and the server would respond with that text. And I can define another route, say /messages, which responds differently, say with some HTML, maybe a list of messages that we pass all at once into this send function. Maybe we're saying hello to our friend Einstein. And we could create another handler for when we get new messages by setting the method to post, and the name of the endpoint remains the same. And we take in these request and response objects always whenever we build up one of these route handlers. And for now, maybe we'll just say console.log updating messages. See how easy it is to set up 3 different routes, each pairing a HTTP method with the name of that route. Express is doing this a lot cleaner than we did in our bare bones example. There's no ugly string manipulation happening here. So let's see what happens when we rerun our server. We can refresh our page to make that request again, and this time we get our hello message with a 200 response from the server. Notice that just like with the 404, we didn't have to specify the status code. Express is handling the most common case of a 200 response, and if I browse to the /messages route, I get my HTML bullet point list. And if we go into our request and the headers, we can see that Express set the content type for us to text/HTML. In fact, even for the previous request with our /endpoint, the content type is still set to text HTML, which is what Express sets it to when we send in a string into our function. But if we change our string to a JavaScript object with an ID and a name, say Isaac Newton, and I think the way it works is we have to say sir, so we can send this JSON object, and if we make that new request, let me clear my log here and refresh the page, our request now has the appropriate content type. Check it out. Application/JSON. What Express is doing is it's looking through all of the registered route handlers one by one, and when it finds a match, it runs the callback that we passed in. And if none of them match, we get that 404 not found. We can already see that Express is doing a fair bit of work for us out of the box. And this is just the beginning. I'll see you in the next one. Welcome back. We're going to be putting together an API by applying what we've learned about our Node fundamentals. But before we get into more coding with frameworks, it helps to get a bird's eye view of the Node ecosystem to see what frameworks are available to us to build our APIs and to compare those frameworks with Express. There are currently a few major players when it comes to frameworks we can use to build Node backends. We need to have the ability to select the best possible framework because building backends and APIs is what Node is best at. And it's something we'll be doing very often. Node is constantly evolving, so it's good to be aware of the best available options before diving in. So let's get to it. Now, all of the frameworks that we'll be talking about in this video are available as packages on NPM, and I'll be posting links to all of them after this video. We start with a high-level view of Express. It's the clear winner when it comes to adoption, usage, stability, and most other metrics. It was created in 2010, not too long after Node was released. When responding to requests, it uses callback functions heavily. And in general, it feels very much like an add-on to Node's built-in capabilities, following the very same patterns that the Node HTTP server is built with. Express focuses on doing a few things really well, like routing requests coming in to different endpoints, being very performant and efficient when handling those requests, and being super reliable and well-tested. The idea with Express was to build something fairly minimal that could be extended with many extra features as needed using a feature that it calls middleware. And middleware allow you to manipulate how you process requests coming in and responses going out to add additional functionality in your server's capabilities. Express has a great website with a lot of different documentation on how to get started and various API references, which includes all of the objects that are used in Express, and even additional resources. The Express project is actually managed by a company called StrongLoop, which in addition to Express, is also the company behind Loopback, which is another framework that builds on Express to try to make it more suitable for applications built by larger enterprises. Loopback adopts the opposite approach from Express. Rather than staying minimal, it takes the approach of convention over configuration. What this means is that it sets up a lot more for us out of the box without us having to configure anything, which means there's less decisions to make and less upfront setup work for us as developers. But this also means that there's more magic happening in the background, which can make extending the framework or debugging your code more challenging than Express, making the learning curve more challenging as well. Next up, we have Koa. Koa is the follow-up framework from the original creator of Express, TJ Holowaychuk. He made this framework to better leverage modern JavaScript features, making use of things like native promises and async await. Koa's design goals were to be more modular than Express, making it easy to design middleware that can be shared between projects, and to be more promise-based, allowing us to use the JavaScript async await syntax as opposed to using callback functions to handle requests like Express. Koa code looks a lot like Express, except instead of passing around request and response objects separately, it bundles them into this single context object. Now, while Express is designed to be fairly minimal, Koa takes this to the next level and really focuses on minimizing built-in features, but instead relying on a very powerful middleware system that allows it to be extended with just about any functionality you can dream of. Again, using that async await syntax that modern JavaScript provides. We're going to be talking all about middleware and how to make use of it effectively in Express very, very soon. Finally, we have Next.js, which is a framework that's centered around simplifying React integration with the server side. And in case you haven't heard of React, it's one of the most widely used, if not the most widely used, front-end JavaScript framework. Next has benefited greatly from React's growing popularity. And because of it, it's being used by some top companies, including Netflix and GitHub. Now, the goal of Next.js is to make it easy to use server-side rendering and other advanced features when making React web applications. Why is server-side rendering so important to Next? Well, server-side rendering is when content on your web page is rendered on the server and not on your browser in JavaScript. So it's a technique that's used for performance and search engine optimization, where rendering work that's normally done on the client side is instead done on the server side. And the server sends back the fully rendered page to the client. So the client, the browser, has to do less work. This generally means that the search engine crawler, for example, that little Google robot that's looking at your page and deciding whether it's ranked highly or not, it doesn't need to render your JavaScript code, which can improve the ranking of your site in the search results. And the other thing is that if the page is being rendered on the server side, then it doesn't need to be rendered on the client side, which means that the first page load is going to be much quicker because the page has already been loaded. Server-side rendering is used to trade off or decrease the amount of work that needs to be done in the browser, but places extra load on the server instead. A trade-off that many websites are happy to make. Now, Next also supports TypeScript to add type checking to JavaScript. It integrates analytics and various other optimizations. It's definitely more of an opinionated framework with a larger list of features and many more decisions that were already made for you. But keep in mind that more features isn't always better. There's definitely a lot of growing interest in Next, and it has a community around it. It's definitely one to keep an eye on. But because of its specialized focus on React and because of its integrations with other technologies, it's not quite as versatile as Express. Not when it comes to building APIs and backends. For example, if you're not using React, well, Next.js won't really do much for you. All right. Now, I know we just covered a lot of different topics. Don't worry if not everything made sense. The most important thing is that now you've had a taste for a few of the most important players in the Node framework ecosystem. We'll be diving into Express in great detail. And there are many, many more frameworks we could talk about. There's things like Meteor and Happy, but these are much smaller players, which aren't used nearly as often. The truth is, all of the other frameworks that we've covered have more in common with Express than they have differences. And once we become experts in Express, we can use that as a foundation for getting familiar with all of those other frameworks. And that'll be a lot easier. Okay, on we go! Welcome back. Let's do a comparison to demonstrate another perfect example of how Express makes our lives easier. Let's create a list of friends that we can query by ID, just like we did before. But how does Express do it? We know that we're going to need a list of friends. which we'll query and add to. And we'll repurpose this endpoint over here to give us that list of friends. In fact, we can start by adding Mr. Newton as our first friend. And again, so the indexes correspond to the IDs, I'm going to add Albert Einstein at ID 0. Now in my send function, I can pass in that array. And Express will set the content type to application JSON because friends is an array of JavaScript objects, as opposed to, say, a string, which would be text/HTML as the content type. But Express gives us another function which we can use to be a little bit more explicit that we're sending JSON. And we use it exactly the same as the send function, but instead we type res.json. And now the data that we pass in will for sure be treated as JavaScript object notation. All right, so that's a start, but how do we get an individual friend? Do we have to parse the URL that comes in through our request? Well, Express has a much better way. We'll create another get route, and as the name, we'll pass in friends / and then use this parameter syntax that Express gives us, where we can type colon and then a name of a parameter, so say ID, or maybe friend ID to be specific, and Express will parse whatever comes after the / as the friend ID. So let's see how to use this. We get the request and the response, and we can create a constant friend ID, which is set to request.params.friend ID. Notice how Express takes the parameter name that we pass in the route over here, and it populates a property on this params object, which is part of the request. So now, because our friend ID is user input, let's be a little bit responsible and do some validation. After all, we don't know what the user put in after /friends. To avoid unexpected bugs and make sure that we know what we're working with, it's always a good idea to validate values that we're not fully in control of. Values like user input. So we'll say if, and actually we'll do an assignment here for the friend that's being selected. So friends at friend ID. Now if the ID that's passed in as a parameter isn't in the friends array, this friend value will be undefined, which means that now we can check in this if statement whether the friend was found by saying if friend. Because undefined is a falsy value, and a friend object is a truthy value. So we'll say if the friend was found, res.json friend. But the friend ID that we're getting from the params is actually a string, because it's being grabbed straight from the URL. So before we index our array, we need to convert it to a number. And again, often you'll see a plus sign used for this, or any number of different ways. But I like to be explicit and say number, and pass in the string that we're converting to a number. Now, what happens if the friend wasn't found? So in our else condition here, well, let's think about this for a second. The user will have typed something like /friend friends/22, making a GET request. So Express will search for the different route handlers one by one, seeing if they match what was passed in the request. So this route doesn't match, but our parameterized route over here does, which means that Express won't return a 404 for this request because it's matched one of our handlers. So if we want to return a 404 because the friend wasn't found, we're going to have to do it ourselves. And we can set the status and send it manually in a few different ways. We can do res.sendStatus, passing in the code for our response. But in general, it's good practice for one of our responses. We should always return JSON, even if it's an error. And we can let the user know what went wrong more specifically than just not found. The way to do that would be to set the status by calling res.status and then chaining the .json function, passing in whatever JavaScript object we want to return back to the user. Maybe we'll set an error property saying friend does not exist. And we could do the same for our other JSON responses. We could do res.status 200.json, and we need to close out this parenthesis. But if we wanted to be explicit, we could always do that, even though Express defaults to sending 200 responses. All right, so I'll remove this comment, and let's see if things work the way we expect. If I refresh the root endpoint here, we get the 404 not found page from Express as we expect because we removed that route and replaced it with the /friends route. So if we get /friends, now we expect to see Albert Einstein and Sir Isaac Newton. All right, that was the easy part. But what happens if we get our friend at ID 0? So far, so good. Can we get Isaac Newton? All right. And does our 404 work? There we go. We've built our first parameterized route with its own error handling. Now we can put whatever we want in this parameter, and we always get friend does not exist. Our code is much cleaner and more resilient to errors than it ever was with the default built-in HTTP module. So far, so good. Let's find out how to add a friend and work with post requests. I'll see you in the next one. Welcome back. So far, we've used the browser to explore our APIs, sometimes relying on the browser's built-in JavaScript fetch function. But there's a better way of exploring and testing our APIs. Postman is the right tool for the job. Postman is a collaborative API testing tool. What does that mean? Well, Postman allows you to create HTTP requests, organize them into collections, and share them with your teammates. It provides some useful features, like integration with REST and SOAP and GraphQL. These are all different ways of making requests against a backend. It also provides automated testing, so you can run your API requests against your server to check that you haven't broken anything in production. There's this design and mock functionality, which allows you to develop your front end against a backend that hasn't been built yet. So your Postman is sending back requests as if it were the actual backend. This is really cool. It also has documentation. So Postman will document your API based on the requests and responses you've made. And it'll also monitor your API by checking this health status and letting you know if, for example, your API is taking a break and it's gone down. And there's also workspaces, so you can share the requests that you've made with your team to make sure that you're all on the same page around how requests and responses look. It's a great collaboration tool. Okay, so these are all great, but how do we use it? Well, first, I wanted to mention Insomnia. Insomnia is another great tool to help design and debug APIs. It's a competitor to Postman with similar features, but I personally find Postman a little bit more fully featured, while Insomnia is known for its simple and easy-to-use user interface. Whichever you choose, they're both excellent tools which will get the job done. Okay, let's check out Postman. We'll start by creating a collection. And we'll call it Express Example. We'll create it. And inside of the collection, we'll add a request, which we'll call get friends. And we'll save that to the Express Example collection. Now I can go to that request and pass in the URL to the endpoint that we want to hit. So localhost at port 3000/friends. I'll save that, and let's send it to the backend. Postman is now making that request to our API and passing back the response, whether it's JSON or XML, HTML, or text. It will parse that response and show us the result here. If we were making a post request, we could set up the body and pass our data by selecting the type. For JSON data, it'll usually be raw. And then we'll select application JSON as the type. And we could also set the headers in our request, or even inspect the headers from the response from the backend, the response to the request that we just made. We can see that Express is setting this X powered by header. We have our content type and a few other things that we'll explore more throughout the course. We can also see that we got a 200 response. The request took 43 milliseconds to complete, and the size of the data in the response is 305 bytes. There's lots of data to explore. And it's super easy to make requests with any HTTP method, including post, put, and delete, but even some very uncommon ones that we'll most likely never see as developers. I highly recommend you check out Postman. It's really a beautiful tool for API testing. Now, before we move on, let's explore how this would look in Insomnia. You can see that the UI isn't too different. We'll start by making a new folder. We'll call it Express, and then we'll add our first request to get our list of friends. And in the URL, we'll pass our endpoint. And we get the very same response, where we can also explore the headers, just like we did before. Two really great tools. All right, I'll see you in the next one. Welcome back. Before we move on, it's getting a little bit tiresome restarting our server over and over after every change, isn't it? Like we mentioned, this is why developers create tools for repetitive tasks. And we know just the tool for this problem. Let's install the nodemon package from npm. We can do npm install nodemon like we did before, but this time we'll pass in an additional flag by writing --save--dev. This is so that nodemon is placed under the development dependencies section of our package.json. Let me show you what I mean. Nodemon is currently installing, and when the installation completes, we can see that it wasn't added under dependencies like Express was, but we have this new section that includes only nodemon, which we'll use to restart our server whenever one of our JavaScript files changes. So what does this dev dependencies section mean? Well, these dependencies are only needed while developing our project, and they're not needed to actually run our project, for example, if we're going to do so in production with our npm start script. Packages and tools used to improve the development experience, things like nodemon, are typically the dependencies that we save as development dependencies. This distinction is also important when you're uploading your package to npm and sharing your project as open source to minimize the amount of packages that your users need to install. It helps to put those dependencies that aren't absolutely required for your project to run under the development dependencies section. Remember this black hole that the node modules creates? We don't want our node modules to grow too large and get out of hand. We want to keep it nice and tidy. And keeping our dependencies well organized in the appropriate categories will help make our package play nice with others. So now that we have our development dependency, we can add a script, say watch, which will run nodemon server.js. And because we only run the watch script in development, it's fine that it's using a development dependency. And let's just verify that this works by running npm run watch. Our server is listening on port 3000, and say I change the name of Sir Isaac to new tune, and I save it, the server automatically restarts. Very nice. All right, we've prevented the node module's black hole. Time to move on to the next video. Welcome back. There's an idea in Express that comes up again and again. It's something that'll really help us understand how Express works. We're talking about middleware. We've mentioned middleware a few times already. How it allows you to add features to your server by working with the incoming request and the response coming out of your server. But middleware is such an important topic to understand when it comes to Express that it's really worth taking the time to really understand it and even make our own middleware, which we're going to do. With that, we can learn not just how Express works, but also how many of the other frameworks that follow the same patterns as Express work as well. So let's get to it. If we think of our API as this box that takes a request as input and processes it with this server that we get from the Express function, and then sends the response as output. Well, middleware are special functions that run between or in the middle of the request coming in and the response coming out of our API. If we break down our Express application, we'll see that it's really just a series of middleware functions that execute in order. When a request comes in, it flows through all of our middleware sequentially, one by one, right up until the response is set and returned back up to the client. Now, bear with me here for a second, and we'll get right back to this diagram. First, let's look at what our middleware functions will look like. These functions always look like this. We take the app object and we call the use function, which will register our middleware with Express, so it knows to run it. And our middleware is this function that we pass in to handle the request and the response. So nothing new here. So far, it just looks like the route handlers that we've written so far. But what differentiates our middleware is this third parameter, which is called next. Our callback function here has the opportunity to work with the request, use the data from it, and take some action before it reaches any of our route handlers. It might log the request coming in, or do some validation on the data that's in that request. Maybe it's checking that the user making that request is logged in and authorized. We'll explore all of these different scenarios throughout the course. Let's look at that next parameter for a second. This is a function that Express gives us to allow us to call the next middleware. So why do we need a next function? When a request comes into our API, the middleware start executing. So the incoming request hits the first middleware, that is the one that was registered first, using the app.use function. And we can see that this middleware has three parameters: the request, which is being made, the response that we're eventually going to send back, and this next function, which is the function that controls the flow of our middleware. So when the next function is executed, the second middleware starts executing. And we're in a similar situation where we can perform some actions in our server in response to the incoming request. Maybe our first middleware logs the request, and the second one validates some data in that request. And our second middleware can choose to call the next function, which again will go down and execute the next middleware, which we might call the downstream middleware. Why downstream? Because it's like a stream of water. One middleware flows into the next. And in this case, we can see that the third middleware here is an endpoint. It's the handler that matches the route the user is requesting. So rather than using the app.use function, our endpoint is using one of the app.method functions, like app.get or app.post. And because this handler doesn't have a next function here, you're effectively saying that this middleware is now an endpoint. That is, it's the last piece of middleware in the chain. It usually sets the response body and returns the flow back up to the middleware above it. So the second middleware continues executing until it returns, and our response trickles up from the bottom back up to the top until all of our middleware has executed and we have our response ready to be sent back to the client. So we see here that the next function is what is responsible for the order of execution of our middleware. It makes sure that we go all the way down, and then as our middleware finish executing, we go back up until all of our middleware have returned. Now, I know that was all pretty theoretical, but don't worry. We're going to really apply everything that we've talked about in this video in the upcoming videos. So I'll see you in the next one. Welcome back. Let's write some middleware that logs our requests and tells us how long it took for them to complete. We're going to register our middleware with Express right above our first route handler here. So we're going to call app.use, and unlike the routes, we don't pass in a name, but this callback function with the request object, the response, and the next function. And I'm going to make this an arrow function, but we could also make this a named function with the function keyword. Now, inside of this middleware, I want to console.log some information about our request. So I'm going to use the template string syntax and put some information like the request method and the request URL. So we can keep track of all of the requests that have come into our server. And because this is middleware and not the final destination, we need to call the next function to ensure that Express passes the request to the correct handler in one of these functions over here. All right, so let's try this out. I'm going to run npm run watch so that NodeMon keeps track of my changes. And our server has started. So let's use Postman to make some requests against our server and check that our middleware works. Let's start with a GET request to our friends collection. And I'll make another request to get the friend.id 0. Now, because that's different than our first request, I'll save that to our collection, and I'll use this save as, calling it get friend or get one friend, and I'll save it. So I can make this request a few times. And in our server, we see the 4 requests that I made. Very cool. Now, just out of curiosity, what would happen if I commented out this call to next? Let me go back to Postman and make a request to get the information for Albert Einstein. But Postman isn't giving me back a response. It's stuck at this loading stage. And finally, the request timed out, and Postman tells us that it couldn't get a response. Without the call to next, Express hangs when it receives the request, and the response is never set in our handlers. So we need to make sure to always call the next function when writing middleware. All right, that was pretty easy, but what if we wanted to log the amount of time that it took to complete this request? We need to keep track of when the request started and when it completed. And we're going to want to log the difference between those two times. So because this is our first middleware, when we enter this function is when our request was received. So we can create a constant called start, which is assigned to date.now, which gives us the current time in milliseconds since January 1st, 1970. So that represents our start time. What happens next? Well, the next function over here is executed, and Express finds the matching route handler, which does whatever it needs to do to set the response status code and the body of that response in JSON. And then that handler returns, and the flow of execution returns to our middleware function right after the next function was called. So right here. And after any actions we do in our middleware, the middleware will return, and Express will send the response back to Postman. So this is our last chance to measure the difference between the current time, the time that the response is being sent back, and the original start time. So our action here is going to be to create a delta variable, which represents the difference in times, which calculates date.now and subtracts it from that smaller start time. So this is the total amount of milliseconds between when the request originally came in and after all the processing was done, the time right before the response gets sent back to Postman. And finally, because this delta is only available after the next function has already completed, well, we need to move our console.log to after we have access to that delta. And then we can log that this was the amount of milliseconds the request took. Let's give this a go and see what happens. I'm going to make a request to get our 0th friend. Looks like that's working. And I'll make one request to get all of our friends. So I need to change that back and send it. And I'll make that request 2 more times. Now in the server, we should see our 4 requests. And none of them are taking especially long to complete, which is good news. But if we take a look at the times that we're getting here, it says that our last request took only 1 millisecond. But in Postman, we can also measure the request time, and Postman is telling us 3 milliseconds. What's up with that? Well, they're measuring 2 different things. Postman is measuring the amount of time it took between the HTTP request being sent and the time that the response made it back all the way into Postman, which is more work than what needed to happen in Express. Express is measuring the amount of time the processing in Node took for that particular request, without measuring the time that the HTTP protocol was passing that data over into Postman. So it makes sense that the times that we get in our log are smaller than the ones from Postman. It's not that one of them is more accurate than the other. It's just that they're both giving us different pieces of information. Let's recap. When our request comes in to our API, it hits our first middleware, which is where we measure the start time for that request. The next function is called, and we only have one middleware, so we skip right to the end point, which in our case had app.get for the /friends collection. The response is set, and our endpoint returns control of the flow back to our middleware, which measures the response time and logs our request. This middleware measures the new time, subtracts the start time from that current time to get the delta, which is the amount of time all of these steps took to complete. Our request is logged, and the response, which was set in our endpoint, has trickled up into our middleware and then back out into Node's HTTP server, which sends it to Postman. And that middleware runs for every single request that comes into our server. We've seen how to build our own middleware. Now, in the next video, let's find out how to use middleware that's already been built for us and really demonstrate why Express is so easy to use when we can leverage the work of all those other developers who came before us. All right, I'll see you in the next one. Welcome back. In this video, we're going to learn all about how Express handles post requests. We're going to create an endpoint to make some new friends and add them to our friends collection. First things first, we need to add a route where we respond to app.post requests on the /friends collection. And as always, we take our two objects. Now with post requests, much more so than with get requests, we're going to be looking at the request object and reading data that was passed in from the client. Data that's in JSON format. The trouble is, our servers don't understand JSON out of the box. If we think back to our built-in Node HTTP server, we had to parse the JSON ourselves for any request that read in JSON data. Now we could do that here, but our convention is going to be to use JSON for all of our requests. And so this is going to get pretty repetitive very quickly. The good news is, if we go to our Express page here, under API reference, one of the methods that Express makes available to us is this .json middleware function. This is a built-in function in Express that understands when a request is being passed in as JSON based on that content type header, and when it notices a request with that application/JSON content type, it'll do the parsing for us. And it'll set this body parameter on the request object, which is perfect for our needs. What we want to do is we want to create a new friend. So let's call it new friend based on the data in the request. And really, the only important data that we're storing for our friends are their names. So what we're going to do is we're going to take the name of our new friend from the request.body parameter, which is going to have a .name property in the JSON. Now here's the important part. This request.body object won't exist unless we parse the JSON using our middleware. So right above our route and below the logging middleware, we're going to add another app.use statement to register our JSON parsing middleware. And it's going to be below our middleware with the timer over here because we want our timer to capture as much of the work as possible. So it should always be one of our first middlewares. Now for our built-in Express middleware, we can just type express.json and call that function, which will return a piece of middleware that looks something like this, but that instead looks at the content type and sets the request.body to a JavaScript object when the contents type is application/JSON. All right, so now our body will be set to the object which was passed into the request, but we still need to set the ID of our new friend, which we'll do on our own so that the client doesn't have to worry about keeping track of how many IDs are currently being used. And if we want the ID to correspond to the index of our array, like we're doing currently, when we add a new item to our array, we'll basically want the ID to be set to the length of that array. So friends.length. Now for our first new friend, the length of our array is 1, 2, and so the new friend is going to have ID 2. It's often helpful for those clients which are consuming or using our API to be able to process as much data as we can in the API automatically without having to force the client to do more work and worry about the state of data in the back end. Beautiful. So now we can add our new friend to our list of friends by pushing it as a new element. And as the response to our post request, if the friend was added successfully, well, let's return the JSON for that new friend. This is in keeping with the idea that all of our requests return JSON, regardless of if it's an error or if it's a successful response. And speaking of errors, when we take in data from the request, it's always a good idea to validate that data. For our name, we're okay with it being just about any string, but we at least want to make sure that the name was passed in and not a property called age instead, or maybe an object with no data at all. So we're going to add an if statement before we create our new friend, which checks if the request.body.name is falsy. So if that name property doesn't exist, we're going to want to set the status to an error status. Let's refer back to our list of HTTP response codes. Our 4 and 500 series response codes correspond to errors. And when the request data doesn't match what our server requires, well, that means that the client is not sending us what we need. So it's a 400 series error. Let's see what we can do. The client error responses include 400 for a generic bad request due to invalid syntax, and then we go into these more specific authorization and authentication errors. We have not found, which doesn't make sense for when we're creating new data unless the request is being made against a collection that doesn't exist. Well, the method is definitely allowed because we expect to be able to post new data about our friends, and we could keep going down this list. But the truth is, oftentimes the most appropriate error is that generic 400 bad request. That's the most appropriate HTTP code for when some sort of validation on the request is failing. So let's return our 400 error and a JSON object which includes an error message, just like we did with our friend not existing, which should use single quotes. But we're going to follow the same syntax with an error property and a message that tells the user why their request failed. Missing friend name. And we don't need to check the request.body to see that that property exists, because we know that the express.json middleware sets the body to an empty object if, for example, no data was passed in the body, or if the content type of the request was something other than JSON. So we can always try to get this .name, and no error will occur. Let's test out our code. We start by adding a request to our Express example collection. And we'll call it post friends. We'll save it. And we'll set the method of that request to post, where the URL is our friends collection. And now the key is to go into this body section and change the type from none to raw and from text to application JSON. Here we can set up the data for our new friends. And we have to make sure to double quote all of our properties, because the data we're working with here is JSON and not a JavaScript object, where objects in JavaScript don't need to be in double quotes, for example, for our name, and their values in JavaScript can be things like functions, which JSON doesn't support. So we just need to be careful when going from JavaScript objects to JSON objects. But the other way around, from JSON to JavaScript, is always safe. All right, so for our new friend, we're going to select Marie Curie, who won the Nobel Prize not once, but twice, and in two completely different scientific fields on top of that. Definitely someone we'd want to be friends with. So let's save our request and see what happens when we send it to our server. All right, we got a response back with the friend we just added. The ID is being set correctly, and our server is logging the request to our friend's endpoint. Now let's just add another friend just to be sure. So this time we'll choose Elon Musk, and we'll send the request. And we should be able to see our new friends when we get the entire collection. Very nice. But what happens if we don't pass in any data at all? Will our validation code work? There's only one way to find out. Send, and we get a 400 bad request with our error response. Looks good so far. Let's see what's happening on our server. Oh no, we have some sort of error that's being printed in our console. Node is telling us, error, HTTP headers sent, cannot set headers after they are sent to the client. Well, this is actually a very common error when you try to do something after already setting the response on an HTTP request. Let's take a look. If our body name is missing, we set the status code to 400 and the JSON response to this object over here, which tells Express that this data is ready to be sent to the client. But now this block of code completes and we continue executing. We still create our new friend object with an empty name. We still push it to our friends array. And then, this is the problem, we try to send another JSON object. We try to respond with two different things. In Express, once you've told it what you're going to send, you can't change your mind. Node is already working to send that data back to the user. And if the data is missing, we shouldn't be creating a new friend anyway. So the solution is to return from our route handler function here if we're sending back this error response. This way, none of the code for the success case gets executed. This is a pattern that you'll see quite often when working with validation logic in Express. So let's make sure our updated code works. In Postman, we're going to send that request with an empty body. And this time, we're still getting that 400 bad request, but hopefully, our server is doing just fine. Now that we've had a taste for how to process incoming data in our Express APIs, let's move on to the next topic. I'll see you in the next video. Welcome back. We've written a fair bit of code, and our application is starting to get a little bit more complex. It's time to start thinking about how we might want to organize our code so that it's more manageable, easier to understand, and also easier to scale, which just means easier for it to grow as we write more code. Most Express applications use what's called the Model View Controller design pattern for exactly these reasons. Talking about the architecture and structure of your code is always a lot of fun, so let's get into it. Model View Controller, or MVC, is a pattern that tells us how to organize the various different pieces of our code based on what they do. Our code is split into the model, the view, and the controller, while we have the user who interacts with these components. These interactions are generally that the user uses the controller, for example, by making requests. The controller understands and processes that user's requests, and then manipulates the model accordingly. For example, by adding or removing data from a database. And when the model is updated by that controller, the views react to those changes, and the user sees the updated data however it's presented by that view. So in Express, the controller is the code or the functions that react to the incoming request and set the response accordingly, while the model is our data. In our example, the data is an in-memory array. But this could be our database, maybe in something like MongoDB or SQL. And the model also includes any functions that we use to access that database. It contains the representation of how the Express application sees that data, which is not necessarily exactly the same as how the data is represented in the database. So the model can translate the data as it lives in storage to how the data is actually used by your application. And the view is how that data from the model is presented back to the user. Sometimes our view is made up of graphs and diagrams, or even entire web applications made in HTML, which are populated by data from the model in response to some user action that was processed by the controller. But in other cases, when you're just making APIs, which are handled by a front end that lives separately, this view might just be the API and the JSON data that we send back through it. Model View Controller doesn't have to be complicated. It's meant to simplify our code and make it easier to understand, which also has the side effect of making it easier to adjust, to add to, and to fix when something goes wrong. If I had to pick the two most important things to look at when judging the quality of some code, I would say, number one, it should be correct. It should do what it says it does. But as the second most important factor, I can honestly say that understandable code is next most important. And when you follow these design patterns that other developers and other programs already use, you're taking a step in the right direction. All right, so if the purpose of each of these components seems clear to you, well done, you understand MVC. And if it's not clear yet, don't worry. We'll learn more about MVC by applying it to our example project in the next video. The important part is that this design pattern can be used to split our applications into these three components, or these three layers, which interact with each other to perform the actions that the user requests. Splitting our applications into these layers allows our code to be easier to read, update, and improve because each layer is responsible for just one thing. We'll keep exploring these ideas in the next video. But also, as our applications get more complex, we'll be coming back to it throughout the course. Now, in your career as a developer, you might also hear about related design patterns, especially from developers who are more familiar with working in languages like Java, C#, or any other language. These related patterns grew out of MVC to better capture some subtle differences that applications have. These include the model view presenter pattern and the model view view model pattern. These might sound complicated, but they're basically just dressed up versions of MVC. If you understand MVC, you'll feel right at home working with projects that use related patterns. Most importantly, in Node with Express, MVC is definitely the way to go. Let's learn more in the next video. I'll see you then. Welcome back. In our previous video, we learned about the model view controller design pattern and how we can use it to organize our applications into these layers of models, views, and controllers, where the user of our application uses the controller by making requests against it, and the controller in turn updates or manipulates the data in the model. And when the data in the model is updated, the view that the user sees as the response is updated with that new model, with that new set of data. But the truth is, we can't truly understand something unless we've applied it a few times for ourselves. Let's jump into our example project and apply what we've learned about MVC to our Express API. We'll start not with our data and not with our middleware, but instead with our route handlers. These functions that process the request coming in and the response going out are going to be our controllers. Those things that interact with actions that the user takes. Actions like making requests. So I'm going to create a new folder, which I'm going to call controllers. And inside of that controllers folder, we'll create a few node files or node modules. The way we're going to break things down is we're going to create one controller module for each of our collections of data. So one for friends and one for messages. When we're working on large servers, this allows us to group together related functionality while still breaking things down into small enough modules that are still easy to work with. So let's create one module. I'll create a new file called messages.controller.js so that when we're searching for files in our project, we know that this file not only relates to messages, but specifically the controller functionality for messages. And I'm going to create another file for our friends, .controller.js. And what I'm going to do is move all of our route handler functions here, like this one which sends some HTML to our user, into our messages controller. And I'm going to name it something. So const get messages equals our anonymous function here, this arrow function. But when we're defining a function at the top level of a file and not passing it in as an argument to a function, it's usually a good idea to use a named function by instead using our function keyword and saying function get messages, request response, and not using the arrow. This is because when we're debugging our Node application and we get one of those error messages, if we're using a named function, Node can tell us the name of the function where something went wrong in the log. Whereas if we use an arrow function, even if we assign it to a variable or a constant like we saw just now, Node won't be able to give us that additional information because it won't know the name of our function. So for that extra debugging benefit, let's write our functions in this way. And I'll do the same for the other messages handler, where we respond to the post request. I'm going to create a function called postMessage. And we don't need this added semicolon. Now, to access these functions in our server.js, we're going to need to export them from our module, which we can do by calling module.exports and assigning it to an object which contains our two functions. So we could say getMessages is going to point to the getMessages function, or we could use the shorthand syntax and just say getMessages, because that's the function we're exporting. So let's do the same for postMessage. And we're ready to import our functions from our controller in our server.js. Now we're going to use our relative imports right below our import of express, and I'm going to say friends controller equals require, and now using our relative import, we're going to pass in the path of our friends controller. So // for the current folder that server.js is in, and then controllers / friends.controller. Now, it might seem like we're writing controller a lot, but we only do this once. And now we can call friends controller .getMessages as the handler for our /messages get endpoint. So we're clear exactly what function is handling our request. And let's do the same for friends controller .postMessage. Wait a second here. I'm being silly. The getMessages function isn't part of the friends controller. It's part of the messages controller. And the same is true for the postMessage function. So let's import that at the top of our file, messages controller, and it's going to live at controllers / messages.controller. Just like that. Let's run our server and make sure that everything else we're doing makes sense. So I'm going to run our watch script, and inside of Postman, I'm going to make a request for getting the messages. I'll save it. And our request is going to be to localhost at port 3000 / messages. We'll save that there, and looks like we're getting our HTML, and the content type is set correctly. Let's keep going. Let's get that friends controller set up. So let's take our function, which is going to be the post request for /friends, and we'll move that into friends controller, saying that function post friend handles our request and response like so. And our next function, which gets all of our friends, so that'll be called our function to get friends. And last but not least, our function to get an individual friend. Function get friend. Let's set up our module exports. Module.exports equals this object, which will be accessible in our server.js, and it'll have post friend, get friends, and get friend. Each of our function names corresponding to one of the endpoints that we're responding to. So friends controller dot post friend. For our get route, it'll be friends controller dot get friends. And for an individual friend, we'll get friends controller dot get friend, singular. We can group our routes together based on which collection they're talking to. And let's make sure we're doing everything right. Let's try getting our friends. And it looks like our friends array is not defined in our controller file. This makes sense because our friends array lives in our server.js. So inside of our friends controller, we're going to need to have access to this friends array which we're pushing to and which we're sending in our response. And the best way to do this is to move our friends array into a friends model that can be accessed wherever it's needed. Our friends array represents the data as it's stored in memory. And to keep things simple, we're sending it back exactly how it's represented in memory. But if we were using something like a database, we might have some transformation functions that would go in that model as well. So let's see how we might organize our code to support working with models regardless of where the data comes from. We're going to make a new folder, which we'll call, that's right, models. And we're going to create a model for our friends using the same naming convention we used for the controllers. So friends.model.js to highlight the difference between the friends model and the friends controller. All right. And inside of this model, we're going to take the friends array from our server.js, paste it in, and we'll keep things simple and set our exports as the friends array directly by doing module.exports equals friends, which means we'll be able to access our friends model in our friends controller by requiring it like so. We're going to set a constant, which we'll call model, and we'll require the friends model using this relative import. So this time, we need to go up using the two dots out of our controllers folder into the parent folder, and from there we can go into models/friends.model. So we're going to do /models/friends.model and import that. And because we're exporting the array directly, we can now treat this module as if it were that array. So instead of friends.push, we'll just say model.push. And we'll do the same when we get our friends, and the same when we get an individual friend. We also need to make sure that we're getting the model.length when we set the ID. And that should be all of the instances of our friends array. So let's give this a go and see if we've written our model correctly. Let's make that get request to our list of friends. That's working, so let's make a new post request. And let's make sure that we're adding a valid friend. So let's set the name with the double quotes to Marie Curie. And let's set that request. Looks like that worked, so we can try to get our friend with ID 2. And if I send that, looks like all of our friends' endpoints are working. Good stuff. Now, what about our views? After all, it's model view controller, and not just model controller. Well, right now our views, if we have any, are these JSON objects that we send back in our response. For example, when we post a friend, the way the user sees that data, if we consider our front end or the client, say Postman, as the user, the way they see our data is as JSON, as the response to that request. We're letting our client be responsible for the rest. We don't have any particular logic around how this data is displayed. So we don't need a folder to organize our views yet. Don't worry, we'll look at an example where we do have some more views in an upcoming video. And we're going to be making use of this model view controller design pattern going forward in this course. So we'll have plenty of opportunities to practice these concepts. For now, notice how our code is now more structured based on what it does. Each module now takes care of a specific concern in our server. And it's clear that, for example, only our friends controller makes use of our model, of our friends array. And the added bonus is that our server.js file is now much simpler to read and understand, which is worth it just on its own. Now, in case you're familiar with other languages, for example, Java, you're probably used to seeing the model view controller pattern done using classes and objects to represent each of the pieces, like the model and the view or the controller. And we can take this class-based approach in JavaScript as well. But the most common way, and the way that I recommend, is to use modules, like we've done here, to represent each of these pieces. This way, you can really take advantage of Node's built-in module system and all the patterns and tools that have been built around it. That's the Node way. And with that, I'll see you in the next video. Welcome back. When we're building large Express applications, we'll often take advantage of this concept called a router to organize the routes in our application into smaller groups. So what is a router? A router is like a mini application, just like our Express application here. It contains its own set of middleware and routes. We use a router to break down our application and make it more modular. And we can create a route by using this Express object called express.router. which we can call to create a new router and assign it to a constant like friends router. We can now add our friends routes on that router rather than adding them to the app directly. So let's replace all of these app objects with friends router objects. And the way we use routers is just like any other middleware in Express applications. We need to make sure to use them by calling this app.use function, just like our other middleware, and calling the friends router to be used as middleware. We also sometimes call this mounting the friends router on the app object. And the special thing that routers allow us to do is that we can mount a group of routes under a specific path. So if we know that all our friends are going to be under the /friends path, just with different HTTP methods and potentially something afterwards, well, we can mount our friends router on the /friends path. And now, when we define the routes in our friends router, we do so relative to where the router was mounted. So our post request is going to be under /friends, so we can remove this part of the name when we name it in the router. From the perspective of the /friends router, this post is at the root, which we write with this /. And we can do the same for our other endpoints, simplifying the path to be relative to the router they're mounted on. We just need to make sure to call app.use on that router so that Express knows to match requests to the routes that are contained within that router. So why do we do this? Isn't this just adding more code? Well, by organizing things in this way, our friends router doesn't need to worry about the other routes in the application. It's kind of like a self-contained application of its own. So what we usually do is we'll have another folder, which might be called routers or routes, and we'll group together our routes into these self-contained routers. Let me show you. So I'm going to create a new file for our friends.router.js, and let's make one for our messages as well. So messages.router.js. And we'll move the router we just created into our friends.router. We need to make sure to import Express so that we have access to our router object. And we'll export that router from this file. Notice how the router only needs to worry about the paths of the friends endpoints in isolation, which means less mental overhead for us to keep track of other code that's unrelated to the routes that we're currently working with. So now in server.js, we can instead import our const friend router, which will be under .routes/friends.router.js. And we'll move our friends controller into that router so we have access to the functions that handle our routes. So I'm going to put this right underneath express. Notice that I separate the built-in imports from the imports that are in my application. This is a convention, again, just to make it easier to see where our code is coming from, whether it's the node modules or our actual application folder with our application source code. So in our server.js, let's make sure that we're using our friend router. We need to be consistent about our naming, so here we're calling it friends router, and here we're calling it friend router, so let's use friends router in both places. And looks like we're all set for our friends. Let's do the same for our messages routes. We'll start by taking the routes that we've defined over here and copying them over to our messages router. And I'm going to use the friends router as a template here, so I'm going to copy that and put it just above our routes. But this time it's going to be the messages controller in all of these cases. And actually, we're just going to take our two routes and move them over here. But instead of adding them to a friends router, we'll say messages router, which will handle these get and post requests, and which will also export. We need to make sure to refer to our messages controller and also to use the relative paths for our routes. So we're going to mount this router under /messages, and we're only going to need to use the slash to refer to the root of the current router. All right, looks like our router file is on the right track. So let's mount that router on the /messages path. So it responds to all the requests that go to /messages. app.use/messages, and then we're going to define this messages router. So let's clean this up here and take the messages router, which we've imported here. So we no longer need the controller. Can delete that. Looks like we're all set. Notice that we've simplified our server.js even more. We now have this hierarchy of routes. So we know that there's two main collections that our application supports. And if we want to understand how either of those collections are handled, we just go to the corresponding router, which then tells us which path combined with a method points to which controller. And the controllers take the incoming request and respond to it accordingly. Now, the same rules that apply to our application routes apply to the routes that are connected to our routers. They still need to respond to the requests coming in, and we can even add custom middleware that applies to just that router. So I could, for example, do friends router.use, and then what does our middleware take? We have the request, the response, and our next function. And in the body of that function, let's say that for friends routes, we want to log the IP address of the machine making the request, which we can easily do by using this request .ip property that Express gives us. So let's say that's the IP address. Now, if we run our server, looks like we made a typo somewhere. Node can't find the module for our friend's controller inside of the friends router. Let's see what the friends router is requiring. So we're looking at the current directory, which doesn't have a controllers folder, because the current directory is this routes folder, or this routes directory. So we need to first go up one folder, and then search for the controllers with our friend's controller. All right, let's try again. All right, another typo it seems. Probably the same problem with our messages router. Yep. Just one dot, should be two. All right, and let's see, our server looks like it's started. Now in Postman, we can make a GET request to our messages collection, and in our server, we just have our middleware that logs how long that request took. But if we hit one of the friends routes, let's see what happens. No response. That's right. We forgot to do the most important thing when we define our middleware, which is calling that next function. So our IP address is logged, but we never get to the actual controller function. The server is hanging because we haven't called next. All right, let's try one more time. There we go. Our IP address is being logged. This ::1 is another way of saying localhost, or 127.0.0.1. The difference being that this is in IP version 6 syntax, and this is in IP version 4 syntax. But both point to our local machine. But notice that this IP address is only logged when we make a request to one of our friends' endpoints, and not when we make a request to get the messages. Check it out. Notice that the URL being logged is the path that we're passing in our router, and not the actual full path to that route. So our logs here are not very useful because we don't know which route is actually being hit. We need to modify our middleware to add something called the request.base URL to the request URL. So we're saying the base URL comes first, and we shouldn't actually need this slash. So the base URL comes first, and then it's the path specific for that router. Let's give this a try. Let's see what happens if we get a messages route, and then we get the friends route. Exactly what we expect. The full path is logged, and the IP is only logged for the request to get the list of friends. Very nice. Now, we've moved a lot of files around, and a lot of code has been moved. As we've seen in this video, it's easy to make little mistakes and typos when so much is going on. If you got lost at any point, you can find a link to the code that we wrote here attached to this video. However, what we've learned is that using our routers and even custom middleware, we can customize how our server reacts with different collections of data. And using our routers, we can create these hierarchies of paths to organize our server when we start getting more and more routes. This is really nice when working with large Express applications. All right, on to the next video. Hello again. What best practices do we use when designing our APIs? How do we decide what to name our endpoints? Or how to break down our functionality into smaller pieces? We'll be following REST, which is by far the most common and important pattern to know when building APIs. When we build APIs that follow this REST pattern, we call them RESTful APIs. And we're not talking about the sleeping kind of REST. Let's go see what REST is all about. The good news is that we've been following this REST pattern already without even knowing about it. We've mentioned things like endpoints being plural nouns, things like friends or messages. And we call these plural nouns collections because they represent collections or lists of the data that we're keeping track of, that's being made available by the server. And we can query these collections by looking up the ID of the item in that collection, or add to and even delete from them using the appropriate HTTP verbs or HTTP methods, one of get, post, put, or delete. These are all important aspects of the REST pattern. All right, so what exactly makes an API RESTful? RESTful APIs are those that follow a certain style or pattern that we use when building HTTP APIs. The REST part is an acronym that stands for, ready for this? Representational State Transfer. This was the name of a very formal paper written by someone called Roy Fielding, who came up with this fairly strict standard on how to talk to servers by using the HTTP protocol. Nowadays, this formal standard has been relaxed, and what we call RESTful APIs follow a set of guidelines and best practices that were derived from Roy Fielding's original paper. The representation and the state both refer to how the server makes your data available. And the transfer part talks about how it's sent back to the user. Let's look at the most important ideas when it comes to how the data is represented and how it's transferred back to the user. The general idea around RESTful APIs that Roy Fielding had was that it makes heavy use of the existing standards of the web. In fact, Roy was the one responsible for the HTTP standard as well. So we have URLs, which allow us to access endpoints that we talk to with the HTTP standard. Putting in a URL in your browser performs a GET request on the server side, while putting data in a form to be submitted makes a POST request to send some new data to that server. And that data often takes the form of JavaScript object notation, or whatever standard format is specified in the content type header, which helps us understand how to work with the data being passed around. REST is all about making use of what we already have on the web in a way that makes sense when we build just about any type of application. And those HTTP endpoints, which we communicate with, represent collections of data that are stored on the server side. We use the get, put, post, and delete HTTP methods to communicate the action that we're performing on that collection of data. And like we mentioned, this only really makes sense when we have a client and a server architecture, where the client displays our data to the user and allows them to perform actions, which are sent to the server, which goes off and performs those actions, updating the data that we've stored, and sends it back to the client. They have two distinct sets of responsibilities. They're both concerned with different things and communicate with each other to get the job done. And our requests are both stateless and cacheable, where stateless refers to that each request is separate and not connected to any state on the client that's not included in the request. So our server isn't keeping track of which requests our user has made today, or in the past hour, or in their current session. We only keep track of the data in our collections. But these are independent of the state of the front end, of the client. What that means is that the client could open a new browser on a new computer, and with the exact same request, they can get back the same data from the server. The opposite of stateless would be an API that tracks user data in a session, which sticks around between requests to the server. For example, in PHP, the server keeps track of this table of all the users which are making requests against it in this session variable. We don't want anything like that in our RESTful APIs, and so Node doesn't include it. So our request keeps track of all our state, which means that we can cache requests by saving the results for future use without having to perform all of those actions again. We can minimize the amount of work that the server needs to do and increase performance without having to worry about the user's data on the client side. We only really need to look at the data on the server side, those collections of data, to see what's been updated or not. And so if we're getting our list of friends and no friends have been updated or removed, well, we don't need to look up those friends all from scratch because nothing's changed. So our requests can be cached, which would be a lot more difficult if we had more state from the front end to worry about. All right, I know we've been talking a lot, so let's look back at our example. It's easy to talk about ideal scenarios and theory. But we've been applying these same practices to our example API over here. Think about what we haven't been doing. I know that's pretty difficult to do, but say we're adding a new friend, which we are doing by posting to the /friends collection. That's old news, but we could have called our endpoint over here like a function. So maybe our function to add a new friend is called create new friend. And we could have made a post request to this /create new friend endpoint, or even done a GET request to /create new friend and used our own custom data format for the data rather than using JSON. It wouldn't be completely unreasonable to do this. After all, we're getting the data that the server sends back when we create a new friend. And in fact, this is how servers used to work before REST. We had what's called remote procedure calls, where clients, like your browser, would communicate with servers by calling functions on that server, as if they were on the same machine. REST became popular because these approaches weren't working very well. They ignore the truth that the client and the server are two separate machines that are communicating over these potentially large distances using the internet. So let's not ignore the truth and do anything like that. And instead, let's follow our RESTful best practices when making our APIs. We'll learn more in the next video. I'll see you then. Welcome back. When we're working as backend developers, we may hear talk about what's called CRUD. This isn't people calling their own code disgusting or nonsensical. When it comes to APIs, CRUD refers to the 4 basic operations that we can perform on data, which is create, read, update, and deleting that data. Nearly every application that we build involves doing a lot of this CRUD. And when we're talking about HTTP APIs or RESTful APIs, the CRUD operations correspond to HTTP verbs. So imagine we're working with a collection of customers. Just like our friends, we could create a new customer by posting to the customers collection. And we could read the list of customers by again making a GET request to the customers collection. Now, all of our CRUD operations can be split into those that are done on an entire collection of data and into those that are done on a specific item in that collection, which we specify with the ID matching that item. So for create operations, it only makes sense for us to post to the entire collection to create a customer and not posting to a specific customer ID because that customer already exists and it's not a collection of any sort. If we wanted to update that customer, we could do that with a put request, which will update the existing data and replace it with the customer data that you pass in the body. But just like posting to an individual customer doesn't make sense, it also doesn't make sense to try to update an entire collection all at once, or at least it's very rare because that would be a very large update. Most of the time, when we're editing our customer data, we're editing one customer at a time. Now, you might also see this rare patch HTTP method, which also updates a specific item in a collection, but rather than replacing it, you only modify specific properties of that customer. Maybe you're just updating their name and not replacing the entire object with the updated version. This way of doing things with the patch HTTP verb is actually far less common than just replacing it with the put verb. As developers, it's often easier to just pass in the entire new object and not keep track of which specific properties were updated versus those that weren't updated. And finally, we have delete, which corresponds to deleting either an entire collection, which is usually not what you want to do. It's rare for an application to clear the entire list of stored customers, unless it's some sort of administration dashboard, which could be the case. But generally, we're deleting individual items or individual customers in this case. When we're working with CRUD operations in our RESTful APIs, we want to make good use of our HTTP status codes to communicate the actions that were performed or the error that happened when trying to perform that operation. And we want to be as specific as possible. Like when we're creating a new customer, we'll use the 201 created response code and not just 200 OK, because it's more specific about what happened in the server. If the operation doesn't make sense, like creating an entry on a specific customer, that is, trying to add an item which isn't a collection. Confusing, right? That's why we don't do it. Well, in those cases, we can use the 404 not found response to say that that endpoint doesn't exist, or we can say that the method is not allowed with the 405 response. Now, don't worry, we don't have to memorize all of these different cases. We can always look up our list of HTTP response codes, our HTTP verbs, and what makes sense for each scenario. And we'll be doing exactly that as we build out our APIs. The important thing that we've learned is that the CRUD operations correspond to the HTTP verbs, and that each of these operations can be done on either a collection of data or a specific item in that collection. These are the scenarios that we need to think about when building our REST APIs. All right, I think we're ready to move on. Let's go. Welcome back. It's fine to send raw data back to the user. That's what we've been doing so far. But sometimes our servers need to send entire files that already live on our server machines back to the client. Express makes it very easy to do exactly that. For our messages collection, maybe one of our friends sent us a message, and it's not formatted as JSON or as HTML, but instead, they uploaded a photo. We'll put our files that we want to make available from our server in a new folder, which we'll call the public folder. And let's say that our friend uploaded this beautiful photo of them skiing in France. How do we now include this photo when a user requests the messages collection from our server? In our messages controller, let's comment out this HTML because we're going to be using another express function that's available on the response object. And that's res.sendFile, which takes the path of the file that we want to send. Something like ski-mountain.jpg. But the sendFile function needs to know the absolute path of this file. Notice that we're in this public folder in our project directory. To help Express find our file, we're going to make use of the built-in path module. We can say const path equals require path. This will let us work with our paths, handling all the different ways that any different operating system uses paths on that kind of machine. This will let us work with paths, handling all the different ways that different operating systems handle paths. So, like on Linux and Mac systems, we use the / to separate the different components of a path, including the folders and the files. Well, on Windows, we use the \, so that path might look like folder files.jpg. So to help us deal with all of these different scenarios, we're going to use the join function from the path module. And we'll call it like so. Path.join, passing in all of the different components of our path. So it's going to be the public folder, and the file name inside of that folder is ski-mountain.jpg. So far, so good. But remember, this needs to be an absolute path from the root of your system. The good news is, Node has a built-in, the __dir name, which is a variable in the Node global built-ins to get the name of the folder where the current file lives. So in this case, we're in the messages controller inside of our controllers folder. And so dir name points to that controllers folder. And now if we're in the controllers folder, we need to go up one level to the root of our project here before we can go into the public folder. So we're going to join one last piece, which is ... to tell Node that our ski mountain photo is one level up from our controller in the public folder with this file name. And that's all. We can copy this and replace our parameter to send file, and our server will now respond to the get messages request with our image. And Express makes our life easy by setting the content type based on the extension of our file name. Let's see this in action. We'll make a request to our messages endpoint, and check it out. we're getting our beautiful image in the response. If we check the headers that were sent back, we can also see the content type was set to image/JPEG. Now, what if we wanted to serve thousands of different files and folders from our Express server? Let's find out in the next video. Welcome back. One really common scenario when working with Node servers is using Node to serve a front-end web application, in addition to an API. It could be a plain old static HTML website, or it could be React, or Vue.js, or Angular, or any other framework. One way we can do this is using the Express static file middleware. Let's add it just above our JSON parsing middleware by using app.use followed by express.static. And the parameter we pass in is a string containing the relative path of the folder that we want to make available from our server. So let's say that we want our public folder. We'll just type in public. So now if we had a website in our public folder, let's say we have an index.html, and we have some boilerplate HTML here. Maybe it's a site where our title is "My friends are very clever," and we want to show an image, maybe our photo of our friend skiing. So we're going to move this into a folder, let's say images, and we can move that in there, making sure to update our messages controller. So now it needs to be public followed by images, and then skimountain.jpg. And I'll clean up some of our comments here. So we want to show this image. With a header where we say France is beautiful. We want our page to look nice, so we're going to use this style sheet that we've already defined. So we're going to make another folder for our CSS in a file called style.css, where we'll use some very basic style sheets to give our page that extra shine. So you can see that even for a very basic HTML page, we now already have multiple files and a folder hierarchy, which benefits from our static file middleware, which serves everything under a particular path. And in fact, just like we mount our routers on a specific path, we could do the same for our site here. So that rather than being made available at the root, we make it available at, say, /site. Let's give this a try. I'll browse to localhost at port 3000, now /site/index.html. All right, our HTML is being served, but looks like our image is not being found. Probably in our HTML, we need to use the relative paths for our CSS and images. Let's give that a try. There we go. Not only is our image showing, but we can tell that the CSS has now been applied. And if we had some JavaScript, say, that was rendering a React page, well, we could serve that in just the same way. Now, I mentioned that the path that we pass into our static file middleware is relative. Specifically, relative to the folder from which you launch your Node application. So if I started the Node application from, say, the routes folder, and I did node ... server.js, our server runs, but now if I refresh the page, notice that Express can't find that file. To fix this, we need to do exactly what we did in the previous video. So I'm going to terminate the server. And now, instead of passing in the path to public directly, we'll use our path.join function from the built-in path module, and we'll join the __ name with the public folder. So now the static file middleware is looking at the absolute path starting from the directory where server.js lives, which is the root of our project, and then only from there looking into the public folder. Which means that if I run the application again, even from the routes folder, notice that I haven't left that folder. Oops. Path is not defined, so I need to remember to require the path module right below Express over here. Path equals require path. And now, if I refresh the browser, everything still works. It's worth noting, if we look at how our server is structured, the part that serves static files over here is not very RESTful. We're not talking to a collection of data and getting an item from it. We're just querying the server by passing in the name of the file, like index.html. Our server isn't sending collections of data to the front end, to the browser, to display however the browser wants. Instead, it's sending the full HTML and telling the browser to just render whatever's in that HTML directly. But that's okay. Not being RESTful isn't necessarily a bad thing if we're serving files as opposed to working with raw data. However, if you expect your Node server to handle many thousands of users, oftentimes it's better to serve your files not from Node, like we've been doing, but instead from a content delivery network. Something like Akamai, which runs a big portion of the internet, or Amazon's CloudFront. This way, you get specialized servers run by these billion-dollar companies to host all your static files, and data that's hosted locally in many different countries. So your users in these locations have the quickest possible access time for those files. So the specialized content delivery network deals with your static files, and Node can focus on what it does best, which is non-blocking asynchronous input-output for all of those RESTful endpoints in your API. Whoa, we've covered a lot already. Think of all these terms that we've been throwing around. All right, But in case we do want to host our files in Node, which is common in smaller or medium-sized applications, well, we now know that it's very easy to do so. And with that, I'll see you in the next one. Welcome back. Remember this HTML that we have? We're serving it up to the browser from our server. What if we wanted to make it more dynamic by populating the content and potentially even the layout based on some state in the server? After all, a lot of the power of sending HTML and other views from the server comes from the possibility of making them more dynamic. We can determine the contents based on some data that lives in the server. To do this, we can use Express's excellent support for templating engines. If we go to the Express site, under Resources and Templating Engines, we can see that Express has this ridiculously large list of templating engines that it supports. My favorite is Handlebars, and it's also one of the most widely used. So that's the one we're using in this example. Handlebars is a more modern templating engine based on the older Mustache engine, which uses these curly braces as placeholders for variables. And the handlebars, these curly braces, look kind of like curly mustaches. Fundamentally, though, all of these templating engines are the same, using slightly different syntax to accomplish the same thing. So once you learn one, you can easily switch to any of the others. So what does a templating engine do? Well, when you run your Express server, the templating engine replaces these variables, marked with our curly braces, with their actual values that come from the Node server. And it transforms that document, which we call a template, into an HTML file to be rendered by the browser. So it allows us to populate our HTML with data before it's sent to the client to be shown to the user. To use one of these templating engines, we need to install the corresponding npm package. For example, to install Handlebars, we're going to run npm install HBS. And I'm going to say --save to make sure that it's saved in our package.json as a dependency. Now that it's been installed, we don't actually need to import or require it into our Node application. Express has a way of loading our new templating engine internally, so we don't have to do it. What we do have to do is tell Express which templating engine we're using and where it can find our templates. We're going to need to go into our Express application settings, which we can find by going to our API reference under Application and scrolling down here to app.set, which is how we set the various different parameters in our application settings, which includes things like how our server handles routing. Say you wanted routing to be case sensitive, you could do that by setting this property to true using the app.set function. And it also includes a setting for templating engines, where we can set the view engine. This is the name of our templating engine, like handlebars or mustache, and the views, which points to a directory where the application's views can be found. For Express to render our templates, we're going to go into our server.js, and right here below where we create our Express object, we're going to say app.set view engine, and the view engine that we installed is handlebars, HBS. And let's create a folder that we'll call views for our handlebars templates. So we're also going to set this views parameter, app.set views, and we want to point it to the path to our views folder. So just like we did before, when we were serving our static files, we're going to use path.join and take the path of the current directory with __ dir name and join that with the views folder. Now Express has all the information it needs to load handlebars internally and to find our templates in our project folder. So let's create a template for our index.html. We can actually take our HTML and move it into our views folder because it's going to be easy to turn into a handlebars template. So I'll move it. And already we can see that we're just going to be adding these handlebars variables. So our title is going to go in the header over here. We're going to have a caption. So we'll say inside of our curly braces, there's a variable called caption. And these are the two things that we want to populate based on data. But we want to be clear. This file is no longer pure HTML. It needs to be rendered by handlebars before we get the page that should be rendered by the browser. So we're going to rename our HTML file to a handlebars file, .hbs. We're now ready to create a route which serves our handlebars template. So in our server.js, let's create a root route for our site, app.use, on the /endpoint, which is our root. And this is going to be a GET request, actually, where we take our request and our response. And just like we did in our messages controller, where we sent a file in response to a request, or even earlier when we sent that HTML text, we're going to do the same with our template. And we're going to use this express function, response.render, to tell Express that we're rendering the handlebars file called index.handlebar, index.hbs. And the second parameter we pass in is an object which has the values for all of those variables in our handlebars file. So title, my friends are very clever. And caption, let's go skiing. And we need to use this backslash to escape our quote symbol here so that our string doesn't get terminated prematurely. I'll add this trailing comma. And let's see if our template actually renders. I'll refresh the page we have over here, except this time we'll be pointing to the root route because it's a endpoint that's returning our HTML template, and it's not that static file middleware this time. And check it out. The title is being set, we can see in our tab over here, and the caption is coming in from our variable as well. Now it looks like we've done something wrong with our paths again, and it has to do with the fact that we've mounted our static files under this /site path. So in our template, when the browser is looking for these files, the CSS and the image, it's looking under site/CSS and site/images. So let's save that and give it another try. All is well. We're serving our page as an Express template with the correct images and CSS being applied. Let's keep going. I'll see you in the next video. Welcome back. We're doing really well. Let's continue our journey in understanding templating engines and how they apply to what we've learned in the rest of this course. Now there's one more really useful feature that's not well documented, and it could be confusing if you're not used to working with templating engines, such as handlebars. And that feature is layouts. With handlebars, if you create a view in a file called layout.handlebars, this file contains all of the common HTML that all of your pages will use, all of the pages with this layout. So what we can do is take our HTML here and move it over to our layout. And now we'll remove everything that's going to change between each page, which is going to be the body. And we'll replace the body here with this special handlebars variable with 3 mustaches, with 3 curly braces. And this is going to be called the body. Now this layout is used by default when we call the res.render function. And the template that we specify, right here, it's called index, only needs to include the templating for its body. So we can include only these headers and images. That's much simpler, right? So now in our res.render function, we're still passing in the title and the caption. And first we go to the layout where the title is set. And then we go into this body for the template that we're naming, so index.hbs. And that in turn will handle the caption and any other variables that we pass to it. So I could also create another template and call it messages.handlebars. And if I include some unordered list here with messages to our good friend Albert. Hello, Albert. What are your thoughts on black holes. But maybe I want to replace the name over here with all of my different friends. So I could replace it with a friend variable. And now in our messages endpoint, I'll comment out this send file and instead render the messages template, passing in a title. So messages to my friends, and a friend, which is going to be Elon Musk. Let's see what he has to say on black holes. So both my messages and my index template here will share this layout for all of the common HTML and all of the common variables like the title. Think we did it right? Let's see. What happens if I go to /messages? There we go. Our unordered list with our friend variable coming in populated by data from the server. And same thing for our root endpoint. Very nice. So we know how to make templates. But where does this all fit in with what we've just learned? We don't want to just memorize what functions to use, but instead we want to learn something. We want to connect all these concepts together to help our brain remember and to really understand how everything fits together, not just in isolation. You see, before the RESTful pattern, with our collections like /friends, before that became the common way of writing HTTP APIs, before that became best practice, it was common to have the view of your website come in through these HTML templates, being rendered in statically in the server, just like we're doing here. We would have all these front-end concerns being done on the backend. The backend would serve up our HTML with the data already embedded inside it. But unless we're doing something like server-side rendering for performance reasons to speed up that first page load, doing this kind of server-side rendering with templates is much less common these days. And REST, with RESTful APIs, helps us separate our concerns so that our front end is doing the majority of the view logic, and our server can deal mostly with these controllers and these models. On the server side, our views are often really simple, with just the data being passed in a form that the front end will then understand and render in a more beautiful way. As we learned earlier in the course, in modern development, we benefit from separating the concerns of the backend and the front end, not treating them as if they're the same machine. Concepts like REST and the model view controller help make our code cleaner, easier to understand, and really fit well with the existing standards of the web. Standards like HTTP, which the web is built on. That's all for now. I'll see you in the next video.